Welcome everybody to the 2023 Level Up Academy. Today's breakout session is on energizing buildings. We have with us today three experts: Miles with Energize Denver, Jim with Golden Real Estate, and Andrea with Energize Denver. And I'm going to hand it over to our experts.
Thank you.
Thank you very much. Hi, everyone. My name is Andrea Salazar. I am so pleased to be here with all of you businesses doing good work. We're hoping to connect our good work with your good work so we can do more good work together. So quick thank you. I'll get out of the slides way. Quick thank you to all of our sponsors, including Michael's Energy, you might notice. And here again, we've got our sponsors with their different things that they are sponsoring and presenting. And look at all these awesome businesses who are participating. Thank you to these awesome businesses who are participating. Just a really good group of businesses and people. So thank you. With that, I'm going to go ahead and get started. So again, I am Andrea Salazar. I am with Michael's Energy. Michael's Energy has been hired by the City and County of Denver to work on their multifamily and commercial building electrification initiative. I promise to explain that. And then we do have Miles here, who's my compatriot at Michael's Energy, working for the City of Denver, and Jim with Golden Real Estate. So here's what we're going to cover today. We're going to talk about an introduction to the Energize Denver program and the electrification program. Miles is going to go a little bit deeper into the rebates that are available, what kind of heat pump opportunities there are out there. I'm going to talk about the processes, timelines, cost, etc. for participating in the program. I have a couple of case studies from our participants so far. And then Jim's going to talk really about a really exciting thing. He has a net positive building in Golden. So that's hopefully going to inspire you all. All right. So let me give you all some background here. So Denver has electrification goals. Promise I will explain electrification. Sounds like a big fancy word. But this is really about greenhouse gas reductions. So you can see here in this graphic that 64% of greenhouse gas emissions are from homes and buildings in Denver. A study was done. And 49 of that, you can see our multifamily and commercial buildings. So that's what we're focused on today. There are programs for single family. I am not the expert, but I know who to point you to. Denver, with their Energize Denver ordinance, is planning to eliminate greenhouse gas emissions by 2040. So that means all new buildings and homes are going to be net zero energy by 2030. And all existing buildings and homes will be net zero energy by 2040. So you might say to me, Andrea, that's great. How does electrification, first of all, what is it? And how does it play into greenhouse gas reductions? So first, what is electrification? Quickly, it is using electricity to heat spaces and water instead of using fossil fuels like propane, fuel oil, and natural gas. And you might say to me, which would be a good question, Andrea, we're just switching from gas or to electricity. How does that save greenhouse gas emissions? And I would say to you, this slide. And what this slide is explaining is that the grid, Excel's grid, which is Denver's grid, is getting greener. You may have heard of this. There was legislation passed that all the utilities in Colorado have to decarbonize 80% by 2030. Excel's doing 85% by 2030, and they've committed to 100% clean grid by 2050. So you can see, I want to make sure to explain any graphs. So this graph shows the tons of carbon emitted per megawatt hour of energy. And where we were in 2020, there's a big drop down to 2030. That's when they get to their 85% reduction. And then out to 2050, they get to a totally green grid powered by renewables. So when you switch to electricity, you are essentially switching to electrons that come from solar, wind, and other renewables. All right. If you have questions on this, I have lots of resources and people and plans and documents that I can point you to. So the grid is going to be green. Not only that, but we are encouraging people to switch not from, let's say, a natural gas furnace to electric resistance heat, but heat pumps. So you may have heard of heat pumps. Quick review on heat pumps. I'm not going to get super technical here. Heat pump works exactly like your refrigerator. Your refrigerator moves heat from the inside where we don't want to heat up our food. It's not a microwave, right? We move it outside. If you go to the back of your refrigerator and check out what's back there, which is always a little scary to do, it turns out it's hot back there because it's rejecting the heat. Okay, a heat pump can do the opposite. So let's pretend we wanted our food to be warm, or maybe our house to be warm, or our building. It can move the heat inside. That's what a heat pump does. Because it's moving heat, it can achieve much greater efficiencies, 200 to 300% efficiencies. So I do want to note, while natural gas is currently cheaper than electricity, that might be a concern. Like, that's great, Andrea, but my my utility bills are gonna go up. Because you're using less energy, right? And because I don't know if you've noticed, but there have been big spikes in natural gas prices and big increases, bigger than historically. Electric has gone up too. I'm not gonna deny that. But we expect gas to keep going up. And if you're using less energy, there is the possibility of coming out even. You got your same bill, but you have a greener option. You're going to be more comfortable. It's going to be better indoor air quality because you're not emitting pollutants into your building. Same bill. Also just wanted to address, if you have heard of heat pumps and heard they don't really work in Colorado because it's too cold. There are cold climate heat pumps these days that work below 0 degrees. New technologies, so these do work. There are also options with backup gas. So you will not be cold because you installed a heat pump. That's not the idea. Denver's not trying to freeze anyone out. To incentivize people to move toward heat pumps, we have rebates. The city of Denver has rebates. First, I wanted to mention we have an electrification feasibility report. So you're not sure if it's right for your building to electrify and turn to heat pumps because what's it going to do to your energy bill? How much is it going to cost, et cetera. This report goes through and compares a gas system to a heat pump system, looks at the upfront costs, the ongoing energy costs, and the social cost of carbon, and helps you determine if it makes sense and it's cost effective to do heat pumps in your building. And the cool thing is you can get these done for free if your contractor that you choose to do this applies for a rebate. You apply for a rebate, or your contractor helps you. Pre-approval is required, so don't get started without us saying go ahead, and go to newdaynewcode.com to find that information out. As far as the actual equipment, so you've decided now, you've done a study, which it's not required to do the study. If you already know you want to do a heat pump, great, do it. But the heat pump rebates cover part of the cost of the equipment. It's intended to cover the difference between what that gas system would have cost you and the higher cost for the heat pump. So you can get up to $120,000 a year per building to install heat pumps. Again, pre-approval is required, so please don't buy your equipment until we talk. But here's the website, denvergov.org/newrebate. And Miles is going to give you a little bit more detail on what types of equipment, what the actual per piece of equipment details are, and what the opportunities are. So I'm going to pass it off to Miles.
Thank you, Andrea. Hello, everyone. Miles Hayes. I'm an engineer with Michaels Energy, so I'm kind of behind the scenes doing a lot of the calculation work, a lot of the boring stuff, number crunching. I'm just going to talk about some of the most common technologies that we are electrifying. Most of these should be familiar. I won't get super technical and boring. I'll start off by saying that these rebates are super exciting. I've supported a number of utility programs over the past years, and Denver's rebates are on another level. So these are pretty exciting rebates, and we hope that they will kind of help to motivate the industry to adopt heat pump technologies. With that, so the first technology, you might be familiar. You see those big clunky things on top of your roof, the rooftop unit. Right now, typical rooftop units, they range from like 2 to 10 tons, meaning 2 to 10 tons of cooling capacity. And usually they're packaged units, meaning that they have gas as their natural gas as their heating source. And the market has rapidly adopted new heat pump rooftop unit technologies that incorporate exactly what Andrea is talking about into a rooftop unit. So our rebates for small and sort of medium-sized rooftop units are between $5,000 and $8,000, depending on the efficiency and the control mechanisms. There's some other specifics in there that you can see on our website, but and then the larger units we have between $8,000 and $11,000 rebates for. So super exciting rebates. And then for some of the smaller systems, so you might be familiar with like your condensing unit in your home. You have like a central air conditioner. It's a lot like that, but it's actually offering heating too. And so if you have a furnace, or maybe if you've got an apartment even, we have mini split air source heat pumps, which are like a split unit. It's got a condensing unit outside and a wall unit on the inside with a refrigeration line going between the two, and heat and cool is rejected in and out of the space. So rebates for those, we have a super high efficiency mini splits that we give $3,000 for. And then, as Andrea mentioned, cold climate heat pumps, which I will reiterate are amazing technologies. I've done a lot of research into them. The last 5 years, they have completely revolutionized the way they operate, and we give $5,500 for those. One other important note, we have what are called equity priority buildings, which are nonprofits and affordable housing, and those rebates are essentially doubled what the standard building rebates are, which is also very exciting to help some of our equity priority buildings. Also, yes. Oh, thank you. There we go. Okay. We also have rebates for your water heater. So you guys are all familiar with the gas water heaters. Heat pump water heaters are the same technology. They pull heat out of the air, and they run it through a refrigeration cycle, and they heat the water in your tank rather than burning natural gas. And we have a different set of rebates for them depending on how efficient the water heater is. Again, I won't get into technicalities, but we have a Tier 3 Plus EcoPort, which the EcoPort basically means that the water heater is set up with the control mechanism that can communicate with the grid. And so if you might be familiar with demand response, I won't get into it, but if you have peak periods, your water heater can actually operate and like optimize for peak periods. So it can communicate with the grid, more or less. And rebates from the different tiers range between $2,500 and $3,500. And again, those double for equity priority buildings. Anything else you want me to add there? Cool. Okay. I'll give it back. Oh, clicker. Too many clicks. There you go. Thank you.
No worries. Oh, you got to give me the clicker. Okay. And I just want to mention the mini splits that Miles mentioned. I don't know if you guys have seen those. They're really common in like Mexico and Europe. They're the ones where there's the wall unit and you have the remote control. So that's what those ones are. Just in case anyone was confused. So, okay, busy slide. Promise to walk you through it. So this is basically the timeline and the process for participating in the program. And when I say the program, I'm talking about getting an equipment rebate, okay? We can talk about the feasibility reports separately if anyone has any questions. Generally, we see those take anywhere from 1 to 4 months, depending on timelines with contractors and getting stuff scheduled. But this is for getting the rebate for actually installing the heat pump equipment. So first you submit an application, simple. And there's going to be maybe some additional required documentation. If we have everything we need, we can turn that around and give you a pre-approval letter. So that'll tell you what your rebate amount would be in 2 business days. What we've seen Okay, we're at the beginning of this program, but what we've seen, we want to be honest and set expectations. It can take up to 1.5 months if we have to go back and forth and determine if your building is an equity priority building, or you have to get this documentation and you have to figure out where to find it. So it can take up to that long. Okay, so next step, you've got that pre-approval letter. That means you can go. Excuse me, that was my timer for Miles, so he did great. So then you work with a qualified contractor, okay? That means they are licensed with the city of Denver. You go on Denver's website, I can show you where to make sure that they are licensed with the city of Denver, okay? You get a bid from them, they get a permit, they install the equipment. What we have seen, again, you all may have heard about supply chain issues, I don't know, and shortages of workers, these sort of things, I don't know. So they're affecting everything, right? All our daily lives, including this. Imagine that. So smaller and less complex projects can take anywhere from 1 to 2 or more months. Larger projects, so a larger project at this point would be, more than one piece of equipment, or even a rooftop unit, which requires usually a crane. So then they have to get a right of way, blah, blah, blah. I'm not going to go into the details. But we've seen that can take at least 9 months. And sometimes that's waiting on equipment, right? Making sure that the permit, going through the cycle of getting the permit. That's what we've seen. After you do your install, you submit final documentation and we review it. So what you're submitting is your inspection, showing that you passed inspection. Again, you're showing your contractor will help you the data sheets for your equipment, making sure the equipment that they installed does still in fact qualify for the program. What we've seen, it can take less time, but we've seen that wrapping up all of that can take up to 2 months. Once we have everything and we've reviewed it and you're good to go, you'll get the final approval letter saying this is your rebate amount. After you get the final approval letter, then in 7 to 10 business days, you've got your rebate check. So really quick turnaround time on the check. You can also assign that check to your contractor. If you are afraid you might have to float the money and you can't do that, you can assign it to your contractor. So that's the process. I do want to give you some costs just to give you some ideas. So before we are looking at these numbers and memorizing them and saying this is the cost, this is not the word of God here or anything. This is data from 6 projects that we have seen come through the program. And these include the cold climate and split and mini splits. So the ones that look and feel just like your regular central furnace and air conditioning ducted system, and then the mini split, which is the thing on the wall that you remote control, okay? And these are 2 to 3 tons, so pretty similar in size. Just want to caveat, again, only 6 data points here. But what we've seen is an average project cost of $17,000. So that's before incentives. I do want to note here that Excel Energy also has incentives. You may have heard of some tax incentives. I am not a tax advisor. Do not ask me anymore, but I shall just say that there are tax incentives. But I am just showing Denver's incentives. So there are more incentives you can take advantage of, and we can talk about Excel for sure. The average rebate from Denver, a little over $5,000. Average out of pocket, $10,400. And we did some math looking at our data, and comparable gas system, so the gas system you would have installed is costing anywhere from $9,500 to $12,700. So it's looking like preliminarily, like our rebates are helping to bring it down, so you're paying what you would have paid for a gas system, roughly speaking. So questions on that? I'll take a question. I'll take a question at the end if anyone has one. But that's what we're seeing. I want to give you two case studies, and then Jim will give you his very exciting net zero. These are just case studies of people going through the program. Jim will really energize you with his net zero building. I don't know if anyone's heard of Earthlinks. They could possibly be here today. Yeah, they should be. If they're not, well, I don't know what they're doing. So they work with unhoused people to give them skills to make lotions, to make candles, to make soaps, chopsticks. You can buy stuff from them. Buy it for whatever holiday you may be celebrating in the near future and give it to people. Candles, honey. They have vegetables that they grow and then sell. They have a coffee shop, so if you just want to go and check it out, go to their coffee shop. Really cool organization. They also help to put people in stable housing, and they have a 75% success rate. So awesome organization. Happy to help them out. So what did we do for them? They had an old rooftop unit that, because of weird configurations of old buildings and mishmash systems, which happens, it was only providing heating. They got a free electrification feasibility report to determine what it would cost. Does it make sense? So then they decided to install a heat pump rooftop unit with gas backup heat. So that was determined to be the most economical for them. And also that was going to make sure that they could stay comfortable given their situation. And then here's some numbers for you. There's a lot in that one little line. So the project cost almost $33,000. I do want to mention that this is actually a project that went through our pilot. So this is where we were trying to learn, like, what are the costs and how much do we need to offer for a rebate and how long does it take? We don't know what's going on. We learned a lot. That's significantly more than was originally estimated. And we've learned that permitting costs to do all the stuff that's required for permitting is one of the things that have made that go up. So I think contractors are getting more familiar with the new permitting requirements, which I won't get into, so they should be able to provide more accurate costs. That said, if they had participated in this standard program that we're offering now, they're an equity priority building, they would have got $10,000. So their out-of-pocket would have been $23,000. And we looked at all of our data. $20,000 would have been a gas equivalent. So again, they would have paid a slightly more, a little bit more, but comparable to what they would have paid for a gas system and gotten a much better system.
The bonus was they had air conditioning.
And now, yeah, they're going to have the air conditioning too. Yes, yes. And since you guys care about this, projected savings of 4.8 tons of carbon, or 12,300 miles of driving. Let's see if I memorized it and don't need to look at my notes. But, oh, that's not where I do that. Okay, so that is the equivalent of driving from New York to Los Angeles, correct me if I'm wrong, 4 times, 7 days. Yeah, so I'm sorry, there was a lot of numbers. 4 times, 7 days in the car with your family. Straight. Yeah. So that's a lot of carbon, right?
Unless you're driving an electric car.
Unless you don't drive an electric car, if you want to know that. But I mean, do drive an electric car, but that would not be this. So I do want to mention, again, this went through our pilot program. It took a year. Not ideal. We learned a lot. So I want to contrast that to a different case study. So LEI Companies is an electrical contractor. They're a minority-owned business. They bought a new building in Lincoln Park right off of 6th and I-25. So this is a picture of their building. They bought it in 2021. They had planned, they needed to do a whole renovation. So they're an electrical contractor. They know what they're doing, right? They have to do all the HVAC, everything needed to be redone, okay? What they didn't plan on was they had a little server room, a little server closet-ish room, and the HVAC system in there failed. Didn't plan on that in their budget. So this is a picture of what a server room might look like in one of these types of businesses. You might also have a desk in there, a couple of desks in there. So you're going to need heating and cooling. So what happened? Failed server room HVAC. What they installed was a cold climate mini split. So yeah, that was a good picture of mini split. That little white thing up there, you remote control that, turn on heating and cooling. Okay. So they installed a cold climate mini split. They got a rebate of $5,500, which covered 40% of their project costs, which made them really happy because they were not planning on any of those costs. And instead of a year, granted this is a little bit less complex project, it took 7 weeks from application to check. So depends on the complexity, but we've learned a lot is the point I want to make. And projected savings, this is much more, 40.4 tons of carbon or 103,500 miles. I got to look at my notes on this one. What is it? It's okay. So 37 times back and forth between New York and Los Angeles, and that means you're basically in the car with your family for 2 months for 63 days, right? Did they? Yeah. So that's a lot of carbon offset.
That's the savings per year.
No, that's the savings. Really good question. That's the savings over the lifetime of the equipment. How long we expect the equipment to be able to run. Very good.
What's that, 20 years?
Yeah, around 20 years, 15, 20 years. Yeah. So with that, I think I'm finished here. I want to hand it off to Jim so he can tell you about what it is like to go net zero. So there you go, Jim.
Okay, thanks.
And there you go.
Okay, so this is our building in Golden, Colorado. You can see that it has solar panels on the roof as well as ground-mounted ones behind the building. And that was done in 3 stages because when we bought the building in 2007, we installed 5 kilowatts of power to cover our electrical needs, which was great. But it was still heated by gas. On the roof, there was and you can sort of see it there. There's an old gas forced air unit, typical of a building that size, with an air conditioning component attached to it, and that's no longer functioning because in 2017 we installed a mini split heat pump system. Sorry? Oh, okay.
Point the clicker that way. It's a little confusing.
Oh, well, it worked. So here in this picture, you can see the mini split heat pump system. That small unit on the wall is blown up on this little thing, and a little picture. And we decommissioned the forced air furnace on the roof. Didn't bother removing it. It's just sitting there. And also notice, by the way, that there are those 2 large white circles are solar tubes, which bring natural light into the office. So we use even less electricity. But then in 2012, we got our first electric car, and then in 2014 a Tesla, and more Teslas. We ended up with 5 Teslas among our agents and me and my wife, and so we installed those extra ground mount solar panels, and with the combination of the electrification of the building, getting rid of natural gas, and by the way, we were able to have the gas meter removed. And that saved us $600 a year, because that's the cost in a commercial installation with Xcel Energy. The base cost of having connection to the gas grid is $50 a month, $600 a year before you burn any gas. So having the gas meter sitting there and not using it anymore was a waste. So I got Xcel Energy to remove it, and that $600 goes a long ways toward electricity. So it's not just a comparison of what the cost of natural gas is and the cost of electricity, which is much lower with heat pumps. that you save a tremendous amount. So we automatically went to net zero energy or beyond, by actually generating more electricity than we needed for the heating, cooling, powering, and charging of our electric cars. We even have two free charging stations for the general public to charge their electric cars. So it was just a no-brainer. I didn't look at return on investment of it because I don't care about return on investment. It cost us about $15,000, I think, to put in the heat pump system. We had no rebates. I'm so impressed at the rebates that Denver is doing. This is amazing. I don't know of any. Is there any other city in the country that's doing anything comparable? Yeah.
Boulder is doing some stuff.
Boulder. Well, you'd expect that from Boulder. Yeah. So we're, they say Golden is becoming Boulder, like Boulder, but you're competing with Golden now. It's in becoming like Boulder. Yeah, bring it on. We just need all the cities in the country to compete with Boulder. So, and really the cooling is such a nice benefit from it. By the way, if you think that heat pumps are new, if you go to Europe, in almost every city that's not a World Heritage Site where they ban it, there are all these compressors for heat pumps mounted on the faces of the buildings. You see them all over the place. On every apartment, you'd see a heat pump, and what that is that's the air conditioning unit for that building. I asked, well, how do they heat? Do they use those for heating? And they said no. Most of those apartments have gas forced air or other fossil fuel heating, but I said, well, couldn't the heat pump do that? Well, the cold climate heat pump is fairly new. It's only been in the last 10 years, or 5 years really, that you could get a heat pump which could extract heat from the outdoor air even when it's 0 degrees Fahrenheit. When I installed in my own home a heat pump hybrid system with the gas backup in 2012, the heat pump component of it could only extract heat from the outside air if it was like 30 degrees or above. And so it had a gas backup. And gas backup was mentioned in an earlier presentation. But nowadays, that gas backup isn't needed. It'd be much smarter to just have resistance-based portable space heaters if it gets to like 10 below zero. But in this building, we had we got heat pump, those resistant space heaters for that possibility, but we never used them. We went through 2 winters, 3 winters, 4 winters without ever needing to use supplemental heating here in Colorado, where it got down to 0 degrees or below occasionally. So really impressive. Of course, it helps to have a well-insulated building. So, and the other thing I mentioned in the bottom paragraph here is the mini splits are amazingly quiet. The quality of the space in that room, that big room with the 3 mini splits, was amazing because it was quiet. These things don't make any noise that you and I can hear, and yet they do a great job of heating the space. And compare that with the air ducts that were there before hanging from the ceiling. You could always tell when the system was running because of the sound of the air whooshing through those heat ducts. The mini split is ductless. There are no ducts, and it's just super quiet. And the heating was very consistent throughout the whole room. In fact, the mini splits that we bought were from Mitsubishi, and they had a sensor which detected where people were in the room, and it had vanes that would go up and down and side to side and would direct air towards the people in the room, which was really interesting, I thought. But at any rate, we were just super comfortable and very warm in the winter and very cool in the summer. Just a great system. And so we're very happy with it. Oops. Okay. Then we sold the building 2 months ago. And we moved into, 2 years ago, we moved into this office in downtown Golden. and it had a gas forced air furnace with an AC unit, and we're on the first floor of a 3-story building, so we couldn't have it on our roof, but we could put it on the roof above, and the pipes ran down. And for heating this room and this office, we put in a cassette, what's called a cassette, that drops into the drop ceiling, and that one unit heats our office just like the 3 mini splits did in the other office. And we got rid of the gas meter, saved another $600 a year, and our total costs, including heating, our electric bill is maybe, we don't have any solar power to offset it here, but because again, we didn't have like our own roof we could put them on. But our total electric bill for heating, cooling, and powering the office is rarely above $100 a month. So that's pretty cool, pretty warm. So, and getting rid of the gas water heaters was a no-brainer too, because in an office you don't need to have like a 50-gallon tank or a really high-capacity tankless water heater. We just had a little 110-volt point-of-use water heater for the restrooms in both offices. So, no, that was just a resistance-based point-of-use tankless water heater. You could buy it for $100 to $200 at Home Depot. So if you have any questions, there's my contact info. I do have handouts here with all these slides on it. These were the vendor we used for both of our installations was GB3 Energy, and I also recommend Sensible Heating and Cooling. And one of the problems is that you'll find that most of the HVAC vendors, they don't really know about heat pumps. And so if your furnace fails, they're going to want to install a new gas furnace, high efficiency gas furnace. This is the thing you should do. A heat pump, no, they're no good below 30 degrees, or because they don't know about the new technology. But the Sensible Heating and Cooling, they will sell you a gas forced air furnace if you insist, but they will try to educate you and sell you on a heat pump system, and I love that about them. Very rare among HVAC companies. So that's all I have. Thank you. How did I do on time?
Just a quick mention. It's both. I just wanted to mention we are working very much with the trades to make sure that we have a list of contractors who know how to install heat pumps. So if you are running into issues and you are not finding, one of our partners, Lashida with Zozo Group, had the exact same thing. A furnace went out. Someone came out and said, you have to install a new furnace. She said, no, what about a heat pump? They said, no, you don't want that. We are collecting a list, and we can refer you to contractors who know how to install heat pumps. But thank you very much, Jim, for the recommendation. Yeah. Did you want to add
Yeah, one quick thing, and also thanks, Jim. I'm gonna stop by your old building. Maybe I'll charge I got an e-bike. I'm gonna go charge that there. I wanted to just add about the water heater. Something I didn't bring up is that a lot of folks are worried about electric capacity, and they do have 120 volt heat pump water heaters now. So usually your mechanical space will have 120 volt electric supply, so you don't have to upgrade your electric service, which is really cool. I just wanted to add that bit.
Yeah. Well, we got rid of our regular cooktop, which was 220 volt, and I was able to use the same line for it, and I did that myself.
Did you do induction?
Actually, we went to a gas cooktop before I realized that was not a smart thing to do, and before I knew about heat pumps. But we sold our house too, so I live in an apartment now, and it's all electric.
So with that, I think we'd like it to open up to questions. And actually, if we could go, so there's Jim's contact information, and there's us too.
Okay.
So we've got both of us. And I uploaded the slides, so they should be available through the conference there, on HOVA. But any questions for us? Yes.
I'm curious, the first building that you electrified and then sold, did that help in the sales process? Was there people looking
Well,
for electrified buildings?
the question was whether being net zero helped to sell it. I wish it would have. I'm a realtor, as you've figured out already, but I have dealt with the fact that people don't even appreciate solar power. It's hard to get more money for a home that has, maybe now you can, but for most of my career, it's been hard to get buyers to appreciate and search out solar-powered homes, much less net zero homes. And I was hoping to sell this building to a company that was really appreciated the net zero, and what I really would have liked to see would be a company like Sensible Heating and Cooling to buy it and have it as a showcase for what they sell. But unfortunately, I sold it to a company that doesn't appreciate that. And I got less than I was asking for the property. They got a great deal, but they don't really appreciate it. They drive pickup trucks, which burn a lot of gas, and they don't have any electric cars. And they actually took out the 5 kilowatt array. I think they're going to reinstall it elsewhere, but well, they.
Now it's on. Oh, switch. Okay.
Is that working?
Is this working? All right. Did we have a question over here? And I will repeat the question. Go ahead.
This is kind of piggybacking from you. Right now it seems like a wash, right? Like you do gas this way, it's about the same amount of money.
Mm-hmm.
And I mean, until that changes, really.
Mm-hmm.
Yeah, carbon, emissions. Yes, everybody in this room appreciates that, but mainstream not so much. So, do you see? Okay, so do you see? 10 years, 5 years, 10 years down the road where it actually is going to be really cost saving so that everybody else really gets it and it's not just the environmentalists.
Yeah. Well, remember the comparison was the cost of purchase. But what if your cost of operation was like a quarter of what it was with fossil fuels? You're saving money over time. And I bought an electric car when it was more expensive than gas-powered cars. Now they're pretty much equal. But even when the Teslas cost $90,000, but I was paying nothing for electricity. I actually had lifetime free supercharging, which is great. But even if I had to pay for the electricity, especially the electricity I'm creating from the sun, no maintenance, no oil changes, no transmission tune-ups or replacements, no engine rebuilds, no catalytic converter being stolen. That's $2,000 right there. The cost of maintenance and operation is so much lower that woohoo, if it costs the same as a gas system, go for the electric because you're going to be saving a lot of money.
But it costs a lot to get in, and that's the problem.
Well,
Yeah.
problem for you.
No, a problem for a lot of people. I mean,
you
I'm
talking
in,
about-
but there's
Are
a
you
lot
talking
of
about
people that
net
can't
zero?
afford that.
You're
Right.
talking about net zero
Yeah.
costs a lot to get in. Yeah. So net zero costs a lot to get in. Denver is defining net zero as electrifying. So you don't have to put solar on because remember, Excel is doing that for you. So if you install heat pumps, you are going to be by 2050, it will be all green electrons coming at you. So you don't have to install the solar. So the cost to get in is really the same as the cost to buy a gas system. Do we
Right.
see that coming down? Yes. Just like
That's the
the
question.
price of the price of electric cars has come down, as more people install these systems, the price is going to come down, and we'll see what happens with the cost of electricity. But yeah, you want to add to that?
Yeah, I'll add to that too. Natural gas has gone up 100% in the last year. I can't, look into a crystal ball, but I would speculate that that's going to continue. But the other thing is so over the last 5 years, cold climate heat pumps, they were astronomically more expensive not very long ago. Today we have cold climate heat pumps that have come down, maybe 30-40% in the last few years, but you look at some of the larger rooftop units that are heat pump rooftop units, those are still super expensive because those are new, like a little bit more newly coming to the market, but they're going to scale up their production. We already have a number of manufacturers that are showing that they're scaling up production, and so as those things scale, I think it's just going to drive down the cost further. But yeah, to your point, it's hard to get in, but if you don't have to get in on the solar, if you just want to electrify a couple systems at a time. One other point, if you have a home, if you're talking about a home, if you have a heat pump and a furnace, there are new technologies to optimize how to control between the split unit and your furnace so that you can reduce your bill as much as possible and have that backup.
Okay.
We have time for one more question.
One more question.
One more question.
Oh, I was just going to mention that. Oh, I guess I'll use the mic. Oh yeah, for the camera. Sorry. Isn't it the case that in 2021 that utility scale solar was cheaper than any other installation?
Cheaper for the utility?
Per kilowatt hour, yeah, because it
I-
finally hit that benchmark where it became cheaper than natural gas and coal and everything else.
Yeah.
And so we're seeing
think.
that change currently.
Yeah.
To answer your question about the
Yeah,
expense.
which is why, I would, again, I don't have a crystal ball. I don't want to promise anything, but I think electric costs are going to be coming down and natural gas are going to keep going up.
Right now, it's equal because solar went back up because of the COVID and everything. But in the long term, it's true what you
Yeah.
just said. It went down, then it went back up.
Yeah.
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 So
And-
it's going to happen regardless.
Right.
Yeah.
And check out what Green Mountain Power in Vermont did. I wrote about this in my Real Estate Today column in the Denver Post last week. In Vermont, the Green Mountain Power is created what they call a virtual power plant. And what they did was they partnered with people who had home battery systems and solar. And now, whenever they have a peak need, they draw they draw power from these 4,500 home battery units to meet the peak needs, and they pay the homeowners to install the units, or if they've done it themselves, they give them a rebate. I forget the plans, but it's amazing. So Google Green Mountain Power virtual power plant. Really interesting idea to eliminate the need not only of creating a separate natural gas power plant to handle peak loads, but to install a solar array, industrial scale solar array to handle peak power needs, and batteries, of course.
20 seconds. One more little piece of that, because this is something I'm particularly interested in, like grid interactive buildings, right? Is virtual power plants. So the other cool thing, if you're paying attention to the EV market, I think Nissan does, but the Ford Lightning has V2G capability, so you can actually pull power from your battery in your vehicle too. So, imagine the day when you can drive and you take all of your power with you. So, hypothetically, we might see a future where your office building, you can plug into your car ramp, and the whole office building could then pull from the car ramp during peak periods. We've got some work to do before we get there, but I think that there's a lot of opportunity.
Any closing comments?
Closing comments. We have materials outside. We have business cards. We really hope that you'll check out the Energize Denver rebates. If you have questions, we are here for you. We will guide you through the process. So just hope that you check us out. And if your equipment isn't failing today, when it is failing, right, it makes sense just to go to a heat pump. So thank you guys very much.